Okay, so next I am going to salt effect andi. So before going to salt effect, we see ionic strength. Ionic strength. Okay, ionic strength is nothing but it is a measure of strength of electric field. It is a measure of strength of electric field present in the solution. It is a measure of strength of electric field present in the solution, or it is a measure of intensity of ions present in the solution. Intensity of ions or strength of ions or concentration of ions, that's why it is said to be ionic strength. Okay, it is a measure of intensity of ions present in the solution or intensity of electric field present in the solution. Okay, generally this ionic strength concept we will get later in electrochemistry also. Okay, this ionic strength concept is also useful to explain, deviation from ideal behavior. To explain deviation from ideal behavior in the case of electrolyte solutions. To explain deviation from ideal behavior in the case of electrolyte solutions. Okay, if you see the formula for ionic strength formula is I is equal to 1 by 2 summation I CI-ZI square. The expression for ionic strength is I is equal to 1 by 2 summation I CI-ZI square. Ci is the concentration of the ion, Z is the charge on the ion. Concentration of the ion, charge on the ion. Okay, so ionic strength includes both concentration as well as charge. Ionic strength includes what? Both concentration and charge. That's why we follow it to explain deviation from ideal behavior. For example, we are taking 1m KCl. It undergoes dissociation, electrolyte solution. It is an electrolyte solution to give what? K plus and Cl minus ions. What is the concentration of K plus ions? 1m. What is the concentration of Cl minus ions? 1m. For example, I am taking copper sulfate. 1m copper sulfate I am taking. What is the concentration of copper 2 plus ions and what is the concentration of sulfate ions? Again 1m only. So in both the cases concentrations of ions is the same. But what about the charges on the ions? Different. Here 1 unit of positive charge, 1 unit of negative charge we have here. 2 units of positive and negative charges we have. Okay, if you consider only concentration, okay, the concentrations of ions in this case and in this case are same. So both may show same deviation if you concentrate only on concentration. But whether both shows same deviation or different deviation from ideal behavior, different deviation. Here charge on the ions is different. Okay, so therefore if you consider only concentration, we cannot explain the deviation from ideal behavior. To explain deviation from ideal behavior, we need concentration as well as charges. So that is considered in ionic strength concept. And so that's why we follow ionic strength to explain deviation from ideal behavior in the case of electrolyte solutions. Right? Next, if you see for 1:1 electrolyte, for example KCl, NaCl, etc. The charge number on cation is 1, charge number on anion is also 1. Charge number on cation is 1. Charge number on anion is also 1. So in the case of 1:1 electrolyte, what is the relation between ionic strength and concentration? What is the relation between ionic strength and concentration? If you see, okay, for example, concentration of KCl is m, and then what is the concentration of K plus ions and concentration of Cl minus ions? And concentration of K plus ions is also m, concentration of Cl minus ions also m. So in this equation, if you substitute I is equal to 1 by 2, I is equal to 1 by 2, summation we have, this summation we have to apply over all the ions present in the solution. This summation we have to apply over all the all the ions present in the solution. Here two ions are there in the solution, K plus and Cl minus ions. So we have to apply to K plus ion and Cl minus ion. So first if you apply to K plus ion, and what is the concentration of K plus ion? M. And what is the charge number on potassium? And 1. So 1 square plus concentration of anion and Cl minus ions, that is again m only, okay, minus 1 whole square. So you may consider or may not consider charge, and since square we have, okay, sign no need to consider since square we have, okay. So therefore we get I is equal to 1 by 2 m plus m, that is 2m. So 2 gets cancelled. So therefore for 1:1 electrolytes, both ionic strength and concentration are same. I is equal to m. So for 1:1 electrolyte, what is the relation between ionic strength and concentration of electrolyte? Both are same. And if you see for 1:2 electrolyte or 2:1 electrolyte, 1:2 or 2:1 electrolyte, for example calcium chloride, 2:1 electrolyte, charge number on cation is 2, charge number on anion is 1. Magnesium chloride, okay, magnesium chloride, potassium sulfate. Potassium sulfate is an example for what? 1:2 electrolyte, charge number on cation is 1, charge number on anion is 2. Okay, now if you substitute in the above equation, I is equal to 1 by 2. For example, I am taking potassium sulfate, and the concentration of potassium sulfate is m. Concentration of electrolyte is m. Now what is the concentration of K plus ions? And 1 mole of K2SO4 gives how many moles of K plus ions? And 2 moles. So concentration of potassium ions is 2m. Concentration of sulfate ions is m only. Concentration of K plus ions 2m. Concentration of sulfate ions m. So if you substitute in this equation, Ci, concentration of K plus ions 2m 1 square plus m minus 2 whole square. So 2m here, 2 square 4, 4m, 4m plus 2m, 6m by 2. So therefore I is equal to what? 6m by 2, that is 3m. So for 1:2 or 2:1 electrolytes, the relation between ionic strength and concentration of electrolyte is I is equal to 3m. Similarly, you simplify for 2:2 electrolyte. Similarly, you simplify for 2:2 electrolyte. For example, copper sulfate, zinc sulfate, etc. 2:2 electrolyte you may derive. Next, 1:3 electrolyte or 3:1 electrolyte, AlCl3, 3:1 electrolyte, copper sulfate. Charge number on cation is 2, charge number on anion is also 2. Okay, next you derive for 1:3 electrolyte or 3:1 electrolyte, that is AlCl3 for example. Okay, AlCl3. Here what we are getting? I is equal to 4m. Okay, if the concentration of copper sulfate is m, concentration of copper 2 plus ions m, sulfate ions also m. 1 mole of copper sulfate gives 1 mole of copper 2 plus ions and 1 mole of sulfate ions. So I is equal to 1 by 2. Okay, 1 by 2 Ci, concentration of cations, that is m, z square plus 2 square, concentration of anions m minus 2 whole square. 2 square, and here 4m, 8m by 2, that is I is equal to 4m. So for 2:2 electrolyte, I is equal to 4m. What about for 3:1 electrolyte? 6m, right? Here if you take the concentration of AlCl3 1m, aluminum concentration, aluminum ions concentration 1m, chloride ions concentration is what? 3m. 1 mole gives 3 moles of anions. So I is equal to 1 by 2, concentration of cations 1, charge number 3 square, that is 9, plus 3m, charge number is 1 minus 1, so square. Okay, here I wrote directly 3 square 9. Okay, so 9 plus, here what? 1m, here 3m, 1m, 3m. So 9m plus 3m, 12m by 2, that is 6m. So like this we can calculate ionic strength of an electrolyte. Okay, so you remember these points. For 1:1 electrolyte, what is the relation between ionic strength and concentration? And both are same. For 1:2 or 2:1 electrolyte, I is equal to what we have? 3m. For 2:2 electrolyte, I is equal to 4m. And for 1:3 or 3:1 electrolyte, I is equal to have 6m. For example, in a given solution, two electrolytes are there. Electrolyte 1 and electrolyte 2. In a given solution, two electrolytes are there, electrolyte 1 and electrolyte 2. The ionic strength of first electrolyte is I1, ionic strength of second electrolyte is I2. Then what is the ionic strength of the resultant solution? Simply what we have here, summation only we have. Simply summation only we have. So therefore the resultant solution ionic strength is nothing but ionic strength of first electrolyte plus ionic strength of second electrolyte. That is I is equal to I1 plus I2. For example, we are taking a solution in which 1m NaCl is there and 1m calcium chloride is there. For example, in a given solution, we have 1m NaCl and 1m calcium chloride. What is the resultant solution ionic strength? I is equal to I1 plus I2. This is 1:1 electrolyte. For 1:1 electrolyte, I is equal to m. So that means 1 only. Plus 1 m. Here 3m. For 2:1 or 1:2 electrolytes, I is equal to what? 3m. So therefore resultant solution ionic strength is what? 4m. Resultant solution ionic strength is 4m. In a given solution, for example, if 1m NaCl and 1m calcium chloride is there, the resultant solution ionic strength is, okay, the sum of the two electrolytes ionic strengths. NaCl 1:1 electrolyte, so therefore I is equal to m, that is 1m. This is 2:1 electrolyte, I is equal to 3m. Okay. For example, we have like this. For example, we have like this 0.5 m KCl plus 2 m copper sulfate. So I is equal to what? Here what we'll get again? 0.5 only. Here for 2:2 electrolyte, what we have, and I is equal to 4 m. 4 m, that means 4 into 2 m, that is 8 m. So we'll get resultant solution ionic strength is what? 8.5 m. Okay. This is the concept of ionic strength. Next we have to see effect of ionic strength on the rate of reaction. What is the effect of ionic strength on the rate of reaction? Next put heading, effect of ionic strength on rate of reaction. Effect of ionic strength on rate of reaction. This is also said to be salt effect. And this is also said to be salt effect. So while we are discussing this, we introduce an equation that is called Bronsted-Bjerrum equation. So based on Bronsted-Bjerrum equation, we can explain the effect of ionic strength on rate of reaction. So that is also said to be salt effect. Okay. Salt effect. What is salt effect? And salt effect is nothing but effect of charges. Okay. Effect of charges on the ions on the rate of reaction. Okay. If you consider a reaction involving ions, what is the effect of charges present on the ions on rate of reaction? That is called salt effect. Okay, right? Consider a reaction involving ions. Consider a reaction involving ions. The effect of charges present on the ions on rate of reaction is called salt effect. Especially it is called as primary salt effect, and secondary salt effect also there, but mostly we are getting questions from primary salt effect only. Okay, and especially it is called as primary salt effect. And briefly I will explain secondary salt effect also later. Okay, so if you consider a reaction involving ions, what is the effect of charges on the ions on rate of reaction? That is called salt effect. Okay, so I am taking a reaction involving ions, and A, charge number ZA, B, charge number ZB. So I am taking a reaction involving ions. So reactants are not directly converted to products according to transition state theory. Initially they form a high energy species, that is what? Activated complex. So let us consider this is the activated complex formed, AB star. Or what is the net charge on the activated complex? And net charge on the activated complex is what? ZA plus ZB. It has same composition with respect to reactants. Activated complex has same composition with respect to reactants. Next, further it may break to give product. So let us consider equilibrium constant as K star and rate constant here as some K dash. So to explain effect of charges and to explain effect of charges on rate of reaction, we consider reaction involving ions with their charges and corresponding charges we are indicating as ZA, ZB. Total charge in the case of activated complex is ZA plus ZB. Now what about rate of product formation? And product formation is occurring in second step. So rate is equal to what? Rate constant into concentration of reactant. So therefore K dash into concentration of activated complex AB star. So V is equal to K dash into AB star. Okay, those who are preparing for GENCO, you may skip this derivation. And okay, here I am giving derivation. So those who are preparing for GENCO, the derivation may not required. Okay, let us consider that is equation 1. Okay, next one, how to write K star and K star equilibrium constant. Equilibrium constant is nothing but product side concentrations by reactant side concentration raised to the powers. The powers are nothing but what? Stoichiometric coefficients present in the balanced equation. Okay, so K star is equal to what? Activities I am taking in here. Since we will take this concept of ionic strength to explain deviation from ideal behavior. In the case of non-ideal solutions, we follow concentrations or activities. And activities we discussed in thermodynamics, concentration is replaced by what? Activity. What is the relation between activity and concentration? And activity is equal to gamma into concentration, where gamma is called as activity coefficient. If you take ideal solution, gamma value is 1. So then both activity and concentration are same. Okay, so I am taking activities. And so activity of AB star by activity of A into activity of B. Activity of AB star by activity of A into activity of B. Now we know activity is equal to what? Gamma into concentration. So if you apply that, activity of AB star, that is gamma AB star into concentration of AB star by activity of A, that is gamma A into concentration of A, next gamma B into concentration of B. Okay, so in equation 1, to give rate equation we need what? Concentration of AB star. So take the expression for concentration of AB star. So take the expression for concentration of AB star. So K star, okay, concentration of AB star, K star into gamma A into gamma B, gamma A into gamma B by gamma AB star into what we have? Concentration of A, concentration of B. So from this, if you take the expression for AB star, K star into gamma A into gamma B by gamma AB star and A into B. And now you may substitute concentration of AB star in equation 1. So from 1 we get V is equal to K dash into concentration of AB star, that is K star into gamma A gamma B by gamma AB star into A into B. I substituted what is AB star. So we know rate equation is equal to what? Rate constant into concentration of reactants. Rate is equal to rate constant into concentration of reactants. And that means in the place of rate constant what we have? And in the place of K rate constant, okay, overall rate constant what we have? K dash K star gamma A gamma B by gamma AB star. So this is the equation we are getting for overall rate constant, observed rate constant. So overall rate constant is given by K dash into K star gamma A gamma B by gamma AB star. Okay, Andy. So rate is equal to what? Rate constant into concentration of reactants. Okay. Now, for example, if you take ideal solution, and if you take ideal solution, for ideal solution, or if there is no effect of ionic strength, no deviation, and so that means no effect of ionic strength for an ideal solution, or if there is no effect of ionic strength for an ideal solution, what about gamma value? And gamma value is 1. So in the case of absence of ionic strength, I am taking rate constant as K naught. I am indicating rate constant as K naught. So K naught is equal to what? Rate constant in the absence of ionic strength. So K naught is equal to what we will get? And gamma values becomes 1. So we will get K dash into K star. Let us consider this is equation 2. Equation 2. So therefore K dash into K star is nothing but what? K naught. What is K naught, Andy? Rate constant in the absence of ionic strength. Rate constant in the absence of ionic strength. Rate constant in the absence of ionic strength. That if you substitute here, so we get K is equal to K naught into gamma A gamma B by gamma AB star. If you bring this K left side, K by K naught is equal to, we are getting gamma A gamma B gamma AB star. Okay, so here K indicates rate constant in the presence of ionic strength. K naught indicates what? Rate constant in the absence of ionic strength. Both rates we are comparing. So what about rate in the presence of ionic strength compared to rate in the absence of ionic strength? Okay, that we are seeing here. K is rate in the presence of ionic strength. K naught is what? Rate in the presence of rate constant in the absence of ionic strength. Okay. Okay, Randy. So we considered this reaction. We wrote rate equation. Rate is equal to rate constant to rate of product formation. Rate constant into concentration of reactant, that is activated complex. So to get activated complex concentration, we wrote equilibrium constant. Equilibrium constant means product side concentrations by reactant side concentrations. Here non-ideal solution. To treat non-ideal solution, we follow ionic strength concept. So therefore, we are taking activities only. But activity is equal to gamma into concentration. So gamma AB star into concentration of AB star. Similarly, gamma A into concentration of A. Activity of B, gamma B into concentration of B. From that we took concentration of AB star and we substituted in equation 1. Next, rate is equal to what? Rate constant into concentration of reactant. So overall rate constant, observed rate constant we are getting like this. This is in the presence of ionic strength. And if ionic strength is absent or if the solution is ideal solution, then gamma values becomes equal to 1. So, and the rate constant we are indicating as K naught in the absence of ionic strength. So K naught is equal to K dash into K star we are getting. That we substituted in this equation. Finally we took K by K naught, the expression for K by K naught. Now if you take logarithm on both sides, if you take logarithm on both sides, log K by K naught is equal to, we will get log A into B. What we get? Log A plus log B. Log A by B, what we get? Log A minus log B. So therefore, log gamma A plus log gamma B minus log gamma AB star. Okay, in electrochemistry we will get this equation. D by Huckel limiting law. According to D by Huckel limiting law, we have log gamma I is equal to minus A Zi square root I. Log activity coefficient of an ion is equal to minus A Zi square root I, where I is ionic strength, Z is charge number on the ion. So this is a de-Broglie limiting law, important equation. Later we will discuss in electrochemistry. Log gamma is equal to minus a Zi square root I. So then if you apply this equation to A, B and activated complex, and if you apply that equation to A, B and activated complex, in each case minus a root I we will get. So I am taking minus a root I common. Here we will get what? Za square plus here Zb square minus what is the charge on activated complex and Za plus Zb. So Za square plus Zb square minus Za plus Zb whole square. So final equation, if you see, log K by K naught is equal to A plus B whole square and A square plus B square plus 2AB. So minus Za square plus Za square gets cancelled. Minus Zb square plus Zb square gets cancelled. So the remaining is what? Minus 2 Za Zb. Minus into minus plus. So the remaining is 2 Za Zb. And so we'll get 2A Za Zb root I. 2A Za Zb root I. This is called as Bronsted-Bejerem equation. So this equation explains effect of charges. See here, effect of charges on the rate of reaction. How charges affects rate of reaction, that we can explain it based on this equation. What is A here? A is a constant, and A is a constant we will get during derivation of de-Broglie limiting law. A is a constant that we will get during derivation of de-Broglie limiting law. So it is a constant. It depends on nature of solvent and temperature. It depends on what? Nature of solvent and temperature. If you take specially solvent water and temperature of 25 degrees centigrade. Okay, if you see the equation for A, and in the equation for A we have solvent parameter and temperature parameter. And if you see the equation for A, in that equation which parameters are present? And solvent parameter and temperature parameter. And that's why it depends on nature of solvent and temperature. If you fix the solvent, that is water, and if you fix the temperature, that is 25 degrees centigrade, A value obtained is 0.51 and exact value is 0.509, or simply we may take 0.51. So if you substitute A value here, we will get, let us consider this is equation 3. So from 3 we will get log K by K naught is equal to 2A and 2 into 0.51, that is 1.02 Za Zb I power 1 by 2. Log K by K naught is equal to 1.02 Za Zb I power 1 by 2. If you take specially solvent water and temperature of 25 degrees centigrade. So mainly remember these two equations, and that is enough. I gave derivation since once a question given in CSIR involving 3 ions, and for that purpose only I gave derivation. And once a question given in CSIR, this type of question, and A Za plus B Zb plus C Zc, so then gives what? Activated complex A, B, C. Okay, what about charge and it? Za plus Zb plus Zc. Okay, so in that case we get log K by K naught expression like this, and log K by K naught similarly if you write, okay, so minus A root I Za square plus Zb square plus Zc square minus here what we get? Za plus Zb plus Zc whole square. And so based on this equation, once a question given, that's why I have given derivation, and right? But you remember just final conclusion. So if you consider a reaction involving 3 ions, and in such case Bronsted-Beecher equation we can write like this: log K by K naught is equal to minus A root I ZA square plus ZB square plus ZC square minus ZA plus ZP plus ZC whole square. Okay, so if you see the final equation, so the final equation we got log K by K naught is equal to 1.02 ZA ZB root I. This is in the form of what? Y is equal to mx. That is in the form of y is equal to mx. So if you take a plot of log K by K naught versus root I, if you take a plot of log K by K naught versus root I, what about slope? 1.02 ZA ZB. Slope is equal to 1.02 ZA ZB. Some simple questions we are getting from this concept and okay, for example, I am taking a reaction involving ions like this and A and B and okay, the charge number on A is for example 2 plus, the charge number on B also 2 plus, and for example, okay, I am taking ions having same charge and okay, reaction involving ions of similar charge, reaction involving ions of similar charge I am taking, for example. Then what about slope? We will get 1.02, charge number on cation is 2, charge number on anion is also 2. So 1.02 plus 2 plus 2. So therefore 4 into 1.02 we are getting. So slope we will get 4 into 1.02. For example, if you take a reaction like this and A2 plus plus B plus, what about slope? 1.02 into 2 into 1, that is 2. So 2 into 1.02 we are getting. For example, if you take a reaction involving okay species like this and for example A2 plus, for example, plus neutral molecule I am taking, A2 plus plus neutral molecule I am taking, for example, then what about slope and okay, slope is equal to what about ZB? 0. ZB is what? 0. Neutral molecule I am taking it. Charge on neutral molecule is 0. So therefore 0 into something is 0. Slope is 0. And in that case slope is 0. For example, I am taking like this A2 plus plus B minus. What about slope? Okay, A plus, first you write A plus B minus and A plus B minus. Plus 1 into minus 1 and so minus 1.02 we will get, minus 1.02. For example, we have like this and A plus B2 minus, for example, then we will get minus 2 into 1.02. Charge number on cation is 1, anion is minus 2, plus 1 into minus 2. ZA into ZB value is minus 2. So we may get slopes like this and so if you take a plot of log K by K naught versus root I, that is in the form of y is equal to mx, so we will get a straight line passing through origin. We will get a straight line passing through origin. And so if you take a graph of okay, so here I am giving numbering and 1, 2, 3, 4, 5. What about the nature of slopes in these 5 cases? And in these 5 cases, what about the slope we will get? And okay, what about the nature of plot? Here straight line passing through origin will get, in each case straight line passing through origin will get positive slope or negative slope andi. Positive slope. In the second case also positive slope, where the magnitude of slope is high andi. In the first case magnitude of slope is high. So in the first case magnitude of slope is high, 1. Next one 2. Next one, in the third case slope is 0 andi. So we will get on x-axis andi. We will get on x-axis. Third one we will get on x-axis. Fourth one negative slope. Fifth one also negative slope. So where the magnitude of slope is high andi, here negative value. Okay, but here 2 times to this one and slope. Here magnitude of slope is high. So this is for fourth one and this is for fifth one. So if you plot a graph of log k by k naught versus root I, we will get slopes like this. Previously questions given and for 4 marks this type of questions. Okay. In DL exam also questions given previously based on this concept. Okay. Next one andi. If you see, we have log k by k naught andi. Log k by k naught we can write as log a by b. Log a minus log b. Log k minus log k naught. So if you bring log k naught right side, it becomes positive. So therefore this equation may be written as log k is equal to log k naught plus 1.02 ZA ZB root I. So this is in the form of what? Y is equal to C plus mx and slope is same 1.02 ZA ZB, but in this case we are getting what? Intercept log k naught and intercept we are getting log k naught. If you take log k versus root I, if you take log k versus root I, nature of slope is same 1.02 ZA ZB, intercept is log k naught. Okay, right? So from Bronsted-Bjerregaard equation, one conclusion is, if you take reaction involving same charged species, if you take reaction involving same charged species, what about the effect of ionic strength on rate of reaction? As ionic strength increases, what about the rate of reaction? Also increases. As ionic strength increases, rate of reaction also increases for the reactions involving same charged species. If one of the reactant species is neutral, if one of the reactants is neutral, then what if the relation between rate and ionic strength? Whether rate depends on ionic strength or independent of ionic strength? And independent of ionic strength. If you take reactions involving oppositely charged species, if you take reaction involving oppositely charged species, as ionic strength increases, what about rate of reaction? Decreases. As ionic strength increases, rate of reaction decreases for the reactions involving oppositely charged species. Write those 3 conclusions. Okay. For the reactions involving same charged species, for the reactions involving same charged species, for the reactions involving same charged species, as ionic strength increases, rate of reaction also increases. As ionic strength increases, rate of reaction also increases. Okay, next one. If one of the reactant molecules is neutral, comma, rate of reaction is independent of ionic strength. Rate of reaction is independent of ionic strength. Next one. For the reactions involving oppositely charged species, for the reactions involving oppositely charged species, comma, for the reactions involving oppositely charged species, comma, as ionic strength increases, rate of reaction, as ionic strength increases, rate of reaction decreases. As ionic strength increases, rate of reaction decreases. Okay. So next one, let us consider, that is equation 4. For example, I am taking like this, and let K1 is the rate constant. Let K1 is the rate constant at an ionic strength of I1. Let K1 is the rate constant at an ionic strength of I1, and let K2 is the rate constant at an ionic strength of I2. Let K1 is the rate constant at an ionic strength of I1, and K2 is the rate constant at an ionic strength of I2. Okay. So then from equation 4, and if you apply equation 4 at I1 ionic strength and I2 ionic strength, and okay, same reaction at two different ionic strengths we are studying, and okay, what about the rate constants? Same reaction at two different ionic strengths, how rates of reaction changes or rate constants changes. Okay. So first, if you apply at I1 ionic strength, what we get? Log rate constant we are taking as K1 log K0 plus 1.02 ZA ZB square root of I1. Next, at I2 ionic strength, and log K2 is equal to log K0 in the absence of ionic strength. So in both the cases that is same. And same reaction we are taking, so therefore charges on the ions also same. Same reaction we are studying at two different ionic strengths, and square root of I2. Equation 5, equation 6. So now final equation, if you do 6 minus 5, log K2 minus log K1, log A minus log B, log A by B. So log K2 by K1, log K0 gets cancelled. Here what is common, and in these two? 1.02 ZA ZB common. Square root of I2 minus square root of I1. So based on this, once a question given in CSIR and for 4 marks, log K2 by K1 is equal to 1.02 ZA ZB square root of I2 minus square root of I1. Okay, this is about primary salt effect. Okay, effect of charges on rate of reaction, that is called primary salt effect. So I explained briefly secondary salt effect, and primary salt effect important, and secondary salt effect. Okay, this is observed in the case of reactions involving ions. Again, this is also observed in the case of reactions involving ions. Okay, where weak acid or weak base is used as catalyst. Where weak acid or weak base is used as catalyst. Okay, in this case what happens, if you see, okay, because of presence of ions, the activity of catalyst may be changed. If these ions disturb activity of catalyst, okay, in such cases also rate of reaction changes or not? Whenever activity of catalyst changes, rate of reaction changes. That is called secondary salt effect. In addition to effect of charges on the ions, if ions disturb what? Activity of catalyst also. If ions disturb activity of catalyst also, then this is called as secondary salt effect. Okay. Right. That's why generally while we are doing reactions, we maintain constant ionic strength, and we have to maintain constant ionic strength. Okay. So what happens if you see, because of presence of ions, and whenever in the solution ions present, formation of ionic atmosphere takes place. In detail we will discuss in electrochemistry. Positive ion is surrounded by negative ions are surrounded by positive ions. So formation of ionic atmosphere takes place, then activities of ions changes. That's why rate of reaction also changes andi. So why rate of reaction changes andi? Whenever ions are involved, due to formation of ionic atmosphere, due to ion-ion interactions, activities of ions changes, then rate of reaction also changes andi. So this is about salt effect andi. So what are the points you have to remember andi on salt effect? What is primary salt effect? And simply the effect of charges on rate of reaction is called primary salt effect. Secondary salt effect, the effect of charges plus next effect of charges on activity of catalyst, that is called secondary salt effect. Next, what is Bronsted-Bjerrum equation andi? Log K by K naught is equal to 1.02 ZA ZB root I. This is in the form of y is equal to mx. The general expression is 2a ZA ZB root I. 2a ZA ZB root I. A depends on what? Solvent and temperature. A depends on solvent and temperature. If you take specially solvent water, temperature 25 degrees centigrade, A value is how much? 0.51. If you take water and temperature of 25 degrees centigrade, so slope you remember 1.02 ZA ZB. Based on that we are getting questions. Based on this plot, repeatedly they are giving questions. Okay. Or this equation also we can write as log A by B, log A minus log B. So if you bring log K naught right side, log K is equal to log K naught plus 1.02 ZA ZB root I. So if you take log K versus root I, slope is 1.02 ZA ZB, intercept is log K naught. And finally we discussed same reaction we are studying at two different ionic strengths. Okay, the rate constants we considered as K1 and K2, then log K2 by K1 is equal to 1.02 ZA ZB square root of I2 minus square root of I1. Okay, and one more equation you may remember, log K by K naught is equal to, we got minus A root I for the reaction involving two ions and ZA square plus ZB square minus, during derivation we got this. For the reaction involving three ions, what we get? ZA square plus ZB square plus ZC square minus of ZA plus ZB plus ZC whole square we will get. Right? Right, just these are the points you have to remember. And for the reaction involving same charged species, what happens? And same charged species, positive slope we will get. That means rate increases with ionic strength. If one of the reactants is neutral, uncharged species, rate is independent of ionic strength. If one of both are oppositely charged species, if you take, rate decreases with the ionic strength. Right. So now write some questions, Andy. Okay కదా. Okay. This is given for 4 marks. In the base hydrolysis of a transition metal complex, transition metal complex, right, Ml6Z plus, in the base hydrolysis of a transition metal complex, Ml6Z plus, the slope between log K by K naught and root I is, the slope between log K by K naught and root I is minus 2.1. The charge on the complex is, base hydrolysis is given. The charge on the complex is options +1, +2, +3, +4. The charge on the complex is close to what? Okay, log K by K naught versus root I. Slope. What is slope? And we have 1.02 ZA ZB we have. Its value is given as minus 2.1. Its value is given as minus 2.1. So 1.02 ZA, the charge on the complex plus Z is given. That we want to calculate. Charge on the metal complex we want to calculate. Charge on B and base hydrolysis is given. Base means OH minus. So the charge on OH end, that is minus 1. So that is equal to minus 2.1. Minus gets cancelled. So Z is equal to 2.1 by 1.02, and that means almost we will get how much? And plus 2. 2 by 1. Nearly 2 by 1 we have. So plus 2 we will get. And option 2. Okay, so next question. What will be the effect of increase in ionic strength? What will be the effect of increase in ionic strength in each of the following reactions? What will be the effect of increase in ionic strength in each of the following reactions? First reaction, pH NH3 taken twice Cl plus NO2 minus. Second one, PtCl4 2 minus plus OH minus. So what will be the effect of ionic strength in each of those reactions? What about first reaction? In the first reaction, as ionic strength increases, what happens? Rate of reaction increases or decreases? Oppositely charged species independent charge ichadu kada decreases, right? As ionic strength increases, what happens to rate of reaction? Decreases. Oppositely charged species is given. What about in the case of second case? As ionic strength increases, rate also increases, since same charged species given. Slope we get positive. Next here it is neutral. So therefore rate is independent of ionic strength. Rate is independent of ionic strength, as one of the reactants is neutral. So next one, Andy. This question given for 4 marks. For a given ionic strength, rate of reaction is given by log K by K naught is equal to minus 4 into, for a given ionic strength, rate of reaction is given by log K by K naught is equal to minus 4 into 0.51 I power 1 by 2. Okay. Which of the following reactions follows the above equation? S2O8 2 minus plus I minus CONH3 taken 5 Br 2 plus OH minus CH3 COO C2H5 plus OH minus H plus Br minus plus H2O2. Which reaction follows the above equation? The above equation you may compare with Bronsted-Bjerrum equation, and you may take ZA ZB value, ZA into ZB value. So, and you may verify in which of these examples we are getting same ZA ZB value. So we have, what is the Bronsted-Bjerrum equation we have? Log K by K naught is equal to 1.02 ZA ZB root I. So in the place of 1.02 ZA ZB, what is given, Andy? Minus 4 into 0.51. So how many times gets cancelled, Andy? 0.51 into 2, 1.02. 2 ones are 2 twos are. So ZA ZB value should be how much, Andy? Minus 2. We have to get ZA ZB value minus 2, and where ZA ZB value? Minus 2. Here minus 2 into minus 1 plus 2 we are getting. Here plus 2 into minus 1. So here we are getting minus 2. So ZA ZB value is minus 2 in the case of second reaction. So second reaction follows above equation. So you may compare the given equation with the Bronsted-Bjerrum equation. So from that you may calculate ZA ZB value, and you may verify from this. Okay. Okay, next one. This is given for 4 marks. The plot of the rate constant versus ionic strength. The plot of the rate constant versus ionic strength of the reaction. The plot of the rate constant versus ionic strength of the reaction A2 plus B minus follows the line. The plot of the rate constant versus ionic strength of the reaction A2 plus B minus follows the line. And okay, this is the plot given. Log K by K naught versus root I. 1, 2, on that line itself 3 given, next 4. Options 1, 2, 3, 4. 4. Okay, we get positive slope or negative slope only? Negative slope. Okay, slope is equal to what? 1.02 ZA ZB. Here ZA ZB value is plus 2 into minus 1, that is minus 2. So minus 2 into 1.02. Negative slope we are getting, that is fourth one corresponding to the given reaction. Fourth one corresponding to the given reaction. Sometimes they are giving matching type of question andi. Okay. Okay, for example, matching type of question andi. A2 plus B2 plus I am giving. A plus plus B2 plus, for example. A plus B minus. Okay. A plus plus B minus, for example. So first curve corresponds to which one andi? First one. First curve corresponds to first one. What about second curve? Corresponds to second one. Third one corresponds to third one. Fourth one corresponds to fourth one. Right? Here we are getting positive slope. Here also positive slope, but here magnitude of slope is high. Next here positive slope in the second case also, but magnitude of slope is low. Here A is neutral species, so rate is independent of ionic strength. We'll get straight line. Okay, on x-axis we'll get here negative slope, we will get oppositely charged species. Next one and okay, this is given for 4 marks. The rate constant for a reaction, A1 plus Bn plus, the rate constant for a reaction A1 plus Bn plus q raised to P is the rate constant for a reaction A1 plus Bn plus q raised to P is measured in two aqueous solutions, of ionic strength 0.01 m, and 0.04 m. 0.01 m and 0.04 m. Continuation. If log K 0.04 by K 0.01 is equal to 0.3, if log K 0.04 by K 0.01 is equal to 0.3, the charge on B is closest to 2. The charge on B is closest to 2. The charge on B, that means N we have to calculate it. Options given 1, 2, 3, 6. Okay, which equation we have to use, Andy? Rate constant at two different ionic strengths. Log K2 by K1 is equal to 1.02 ZA ZB I2 power 1 by 2 minus I1 power 1 by 2. Okay, so log K2 by K1, K8 ionic strength of 0.04 and K8 ionic strength of 0.01. That is log K2 by K1 is given as 0.3. ZA, charge number on cation, given plus 1. Charge number on anion plus N, that we have to calculate. Square root of 0.04 and this we can write as what? 4 into 10 power minus 2. Square root of 4 is 2. Square root of 10 power minus 2 is 10 power minus 1. 2 into 10 power minus 1 and that is 0.2. 0.2 into 0.2, 0.04. And this is what? 10 power minus 2. Square root gets cancelled. We will get 10 power minus 1. 10 power minus 1 means what? 0.1. 1 by 10. 0.1. Okay, 0.1 into 0.1. 10 power minus 2. So here 0.2 minus 0.1. 0.1. So 3 times gets cancelled. So n value 3 by 1.02. Almost 1. So that means close to 3. Charge number on B is close to what? 3. Option 3 and okay, now we see some questions based on ionic strength and okay. This is given in CSIR for 4 marks. Identify from the following. Identify from the following. Identify from the following. Identify from the following. The correct ionic strength for. The correct ionic strength for. The correct ionic strength for A and first solution A. The correct ionic strength for A 0.01 molal 0.01 molal solution of NaCl. Second one and 0.01 molal solution of Na2SO4. Directly tell me Andy. What is the ionic strength for 0.01 molal solution of NaCl and 0.01 molal solution of Na2SO4? It is a which type of electrolyte Andy? 1:1 electrolyte. I is equal to what? M only. That means I is equal to what we get? 0.01 molal given. So small m I am using molal. Next Na2SO4. Which type of electrolyte Andy? 1:2. For 1:2 electrolyte we have I is equal to 3m. So I is equal to 3m. Concentration is given 0.01. So 0.01 into 3. 0.03 m. Small m. Molality is given. Otherwise, to remove confusion, you may use like this and I is equal to C. I is equal to 3C. 2:2 electrolyte, I is equal to 4C. 1:3 electrolyte, I is equal to 6C. Next one Andy. This is given for 2 marks. The ionic strength of a solution. The ionic strength of a solution. The ionic strength of a solution containing. The ionic strength of a solution containing 0.008 m. 0.008 m AlCl3, 0.008 m AlCl3 and 0.005 m 0.005 m KCl is the ionic strength of a solution containing 0.008 m AlCl3 and 0.005 m KCl is. Ento vastundandi. I is equal to what అండి? I1 plus I2 resultant solution ionic strength. I1 it is a 3:1 electrolyte. For 3:1 electrolyte what we have? 6C and for 1:1 electrolyte C only. Okay, this is the concentration of what? AlCl3 అండి. This is the concentration of KCl. So 6 into concentration of AlCl3 and 6 into 0.008, 0.048 plus 0.0 5. So therefore we get 0.053 m, and m is given. That is the resultant solution ionic strength, 0.053 m. Next one, this is given for 2 marks. Okay, the concentration of magnesium sulfate solution, the concentration of magnesium sulfate solution, the concentration of magnesium sulfate solution having the same ionic strength, having the same ionic strength as that of a 0.1 m, 0.1 m Na2SO4 solution is 0.1 m Na2SO4 solution is options 0.1, 0.05 m, 0.075 m, 0.025 m. Okay, what is the question, Andy? For what concentration of magnesium sulfate, for which concentration of magnesium sulfate both magnesium sulfate and 0.1 m Na2SO4 have same ionic strength? The condition given here is ionic strength of magnesium sulfate and ionic strength of sodium sulfate should be same. Okay, right? Magnesium sulfate, which type of electrolyte, and 2:2 electrolyte. For 2:2 electrolyte, I is equal to have 4C, right? 4C concentration of magnesium sulfate. For this is which type of electrolyte? 1:2, so 3C. Now concentration of Na2SO4 is given, concentration of magnesium sulfate we have to calculate. So concentration of magnesium sulfate is equal to 3 into concentration of Na2SO4, 0.1 by 4. 3 by 4, 0.75. 0.75 into 0.1, 0.075. So option 3, 0.075 m. Okay, last question. This is given in AP PhD entrance, Andy. Okay, what is the ionic strength of 0.01 mole per kg magnesium sulfate? 0.01 mole per kg magnesium sulfate ionic strength and enta andi? Magnesium sulfate, which type of electrolyte? 2:2 electrolyte. That means I is equal to 4C. That means 0.04 moles per kg. Molarity is given. Right. This is about ionic strength and effect of ionic strength, okay, on rate of reaction. So with this chemical kinetics completed, Andy. Right. Now take a break for 20 minutes, Andy. Right. After that I will start atomic structure. Right.